Welcome to our tutorial about applying the Kfactor. Let's begin with a new file, a metric sheet metal part document. And let's activate the line tool. Right-click, Done. Let's activate the line tool again. Right-click and Done, and let's dimension our lines. We'll make this one an align dimension. 5 millimeters. OK. And 5 millimeters down here as well. Now let's apply an angular dimension, let's say 45 degrees. OK. Right-click, Done. Let's select this line and convert to construction geometry. And we're ready to exit our sketch. Let's activate the Contour Flange tool now. We're going to learn about this tool later in this course. For now, I'm going to select this profile. Distance, let's enter 5 millimeters. And click OK. Next, let's create a new sheet metal rule. We click on Sheet Metal Defaults. Open the Styles Editor. Click on New. Let's give it a name, 1 millimeter. OK. Thickness here, let's enter 1 millimeter also. And save. Now let's create an unfold rule. New. We'll call it 42 Kfactor. OK. Kfactor value, let's enter 0.42. Click Save. And Done. And let's apply this rule. I forgot to change the unfold rule. Let's go back to the Styles Editor. Under Unfold Rule, let's select my new rule and save. Done. Apply. All right. Now we've got a 1 millimeter thick sheet metal part with a Kfactor of 0.42. Let's cancel out of the Sheet Metal Defaults window. And now let's calculate the bend allowance for this part. We'll go to the Manage tab. Click on Parameters. Here you see the thickness. It's at 1 millimeter. The bend radius is equal to the thickness. The bend relief width is also equal to the thickness. The bend relief depth is equal to the thickness multiplied by 0.5, or basically half the thickness. We'll look at this in more detail later in this course, but for now, let's create a new user parameter. Bend allowance. Units will be millimeters. And now let's notate the formula that we learned in our previous tutorial. Don't be shy, I know you've got it memorized. Okay, pi multiplied by the bend angle, here it's 45 degrees, or D2, divided by 180 degrees, multiplied by the bend radius, plus the Kfactor, that's 0.42, UL, unitless, multiplied by the part thickness. And let's close our parenthesis. Click outside to register the value. We've got the result for our bend allowance. It's 1.115 millimeters. Let's click Done, and let's go measure the bend allowance. Before we measure, we're going to need to unfold the part. Let's go to the Sheet Metal tab and click on Create Flat Pattern. If you don't see the Flat Pattern panel, right-click on the ribbon, select Panels, and select Flat Pattern. OK, let's go to the Tools tab. Activate the Distance tool. We're going to measure the bend allowance length now. Right now our precision is set to 3 decimal places. Let's increase the precision. I want to set it to 6 decimal places. OK, that's a little easier to see. We right-click, select Precision, and we select the number of decimal points we want. Now let's measure the distance again. Here we have our results, which match our results from the formula. Let's go and change the bend angle now. Go to Folded Part, expand Contour Flange 1, and right-click on Sketch 1. Let's make it visible. Select Visibility. Now let's double-click on the angle. Let's make it 60 degrees. Click OK. Click Update. Let's go to the Manage tab now, Parameters. Here is our result, updated in the table 1.487021. Let's click Done, and let's go measure that bend allowance again. Double-click on Flat Pattern. Now go to the Tools tab, select Distance. And we have our bend allowance displayed right here, 1.487021. With the part unfolded, let's return to Parameters. You see the display of parameters is now different. Right now we've got bend allowance displayed as BA. Let's click Done. Go back to the Sheet Metal tab. And let's fold our part up. Go to Folded Part. This concludes our tutorial on applying the Kfactor.